This formula is a real gem, as it allows you to calculate the area of triangles knowing only the lengths of their sides. That is, you don't need to know the height of the triangle, nor do you need to apply the Pythagorean theorem. If you want to know how to use this formula, please keep watching, because today I'm going to tell you everything about Heron's formula. Let's get started. Let's consider a triangle with sides A, B, and C. Heron's formula says that the area of the triangle is calculated by taking the square root of this product. Notice that the product is S times S minus A times S minus B, and times S minus C, where S is the semi-perimeter, that is, it's half of the perimeter. So for the perimeter, which would be A plus B plus C, look, you would have to divide it by 2. I'm going to do 3 exercises, and I'll leave one as homework for you. All right, let's go with the first one. I want you to notice that the first exercise is quite simple, and in fact, we can calculate its area directly with the formula base times height divided by 2. In this case, it would be 4 times 3 divided by 2. That would give me 6 square centimeters. So the area of this right triangle is 6 square centimeters. I already know that, but I need you to see how we can apply this formula. And you'll notice that it has to give us exactly the same result. 6 square centimeters. So come on, let's use it. The first thing I recommend you do is label each of your sides. That is, you're going to say which one is A, which one is B, and which one is C. It doesn't matter which one you choose. I'm going to say that this is side A, this is side B, and this is side C. Again, it doesn't matter how we choose them. So the first thing we're going to do is calculate the semi-perimeter. So I'm going to add 3 plus 4 plus 5. That would be the perimeter, right? But since it's the semi-perimeter, we have to divide by 2. 3 plus 4 is 7, and plus 5 is 12. So I end up with 12 divided by 2, which is equal to 6 done. The semi-perimeter is equal to 6 centimeters, which is half of the perimeter. And now we're going to go straight to the formula for the area. It says that the area has to be equal to the square root of S times S minus A. But S comes out to 6. So I would have 6 times 6 minus A, that is, times 6 minus 3. Then this times S minus B, that is, in this case, times 6 minus 4, which is the value of B. And finally, this times S minus C. That is, in this case, times 6 minus 5 done. So we do the operation of what's inside the square root. So I end up with the square root of 6 times 6 minus 3, which is 3 times 6 minus 4, which is 2, and times 6 minus 5, which is 1 done. This is the operation we have to do now. So we multiply 6 by 318, by 236, and by 136. So I end up with the square root of 36, which is 6. And now we know the area is 6. And in this case, the units will be square centimeters. Done. It's worth mentioning that in this case, it's just a coincidence that the semi-perimeter turned out to be 6, and the area also turned out to be 6. It's just a coincidence, okay? No, obviously it's not always going to turn out like this, but this is the correct way. Done. Now we know that the area of this right triangle is 6 square centimeters, and we had already said that it had to give us exactly that, right? So that means everything is fine with the formula. Let's move on to another one that's a little more complicated. In this case, we have an equilateral triangle, so it's not worth saying which one is A, which one is B, and which one is C, because they all measure the same. So come on, let's start by calculating the semi-perimeter right away. The semi-perimeter would have to be 3 plus 3 plus 3 divided by 2, right? Right away, 3 plus 3 is 6, and plus 3 is 9 divided by 2. And this gives me 4.5. I'm going to leave it as 4.5 for now. But we agree that it would be the same as writing 9 over 2. Now let's substitute directly into the area formula. Look, right now when I write the area formula, I could just use the calculator and do the calculation. But for this video, I need to give you the exact result. So for that reason, I'm going to have to work, sorry, with some numbers. You'll notice it. Let's continue. So I have that one, which we said was 4.5 multiplied by s minus a. That is 4.5 minus whatever a is. But a, b, and c all have the same value. So we're going to write minus 3. And instead of writing 4.5 minus 3 times, 4.5 minus 3 times, 4.5 minus 3. I'm going to write it as the quantity. 4.5 minus 3 cubed. That's equivalent, right? Then writing everything else. So let's continue. So I end up with this being equal to the square root of 4.5 times 4.5 minus 3, which is equal to 1.5. And now, this is raised to the third power. Let me convert it to a fraction now, so I can work a little more comfortably. I'm going to write 4.5 as 9 over 2, and we're going to multiply this by 1.5 raised to the third power. 1/5 is the same as 3 over 2/8, right? So, 3 divided by 2 is 1.5. So I'm going to write it as 3 over 2, and let's not forget that this is raised to the third power. I insist, put this operation into the calculator and it would give me the area result, but I need to write the exact result in simplest form, so I'm going to continue. So I end up with this being equal to the square root of 9 over 2 times. And here, allow me to do something. Look, this 3 cubed I can write as 3 times 3 times 3. But you'll agree with me that this is the same as writing 9 times 3, right? 9 times 3 is still the same as 3 cubed now. We're going to divide this by 2 cubed, but it's the same thing. 2 cubed is the same as 2 times 2 times 2. So I can write this right away as 4 times 2. Look, 4 times 2 is 8. It's the same as 2 cubed, which is also 8. And 9 times 3 is 27, which is the same as 3 cubed. Now this is important. Don't get lost. Let me rewrite this, but in a slightly smarter way. What do I mean by that? Look, I can write 9 times 9 right away as 9 squared. This 9 times 9, that's in the numerator, and this is being multiplied by 3. I'll leave that as it is. Now, in the denominator we have 2 times 4 times 2. I can write 2 times 2 first, which is the same as 4, right? So 2 times 2 is 4. Now, this 4 times 4 would be the same as writing 4 squared. So in the denominator, I'll write 4 squared. Look, 4 squared is 16. And here we have 2 times 4, which is 8, and times 2, which is 16. So these operations are equivalent, right? The reason I'm writing it this way is because I already know that the square root of 9 squared is 9, and the square root of 4 squared is 4 therefore. I could take them out of the root, so then I have a 9 outside. Look, I can take it out now, because I'm taking the square root of 9 squared and the square root of 4 squared is 4, so I can take it out now. Which one can't I take out? Well, the 3, so that one stays inside the root. Done. The exact value of the area, let me write it here, is 9 over 4 times the square root of 3, or 9 over 4 times the square root of 3, and the units are square meters. Done. This is the exact value of the area of my equilateral triangle that I have here. Let me show you a part of this video where, as you can see, I already explained this same exercise, but I did it using a direct formula. And as you can see, we arrived at exactly the same result. 9 over 4 times the square root of 3 square meters. So that means what I did was correct. Let's move on to exercise number 3. I want you to notice that I could have done the first exercise directly with the formula base times height divided by 2 and the second exercise as well. I also could have done it directly with the formula we saw in previous videos, which is used to calculate the area of equilateral triangles. But in this case, notice that we have this other triangle. Here, we have no other option but to calculate it directly with Heron's formula. Or we could also calculate it directly with the Pythagorean theorem. But believe me, it's more complicated to do it with the Pythagorean theorem. Anyway, I'll also solve it in upcoming videos so you can see that it has to give us exactly the same result. So let's get started. We start by calculating the semi-perimeter. So, I would have 6 plus 9 plus 7, and this has to be divided by 2. Well, I didn't write it down, but I'm saying that this is A. Then here, I'm saying that this is B, and I'm saying that this is C, right? It doesn't matter, like I said, because in the end, I'm adding 6 plus 9 is 15, and plus 7 is 22. So I end up with 22 divided by 2, which is 11. And the result in this case will be in centimeters, since we're talking about a semi-perimeter. Now let's move on to the area. We write that the area is equal to the square root of S, which is 11, times 11 minus A, that is 11 minus 6, times 11 minus B, that is 11 minus 9, and times 11 minus C, that is 11 minus 7. All right, let's do these subtractions before we continue. So I have the square root of 11 times 11 minus 6, which is 5 times 11 minus 9, which is 2, and times 11 minus 7, which is 4 done. Notice that 11 is a prime number, 5 is a prime number, and 2 is a prime number. See that the only one with an exact square root is 4. So I'm going to take it out right away, okay? That way I'll have the exact result. The square root of 4 is 2, so I can take it out as a 2. And then inside the radical, I'm left with 11 times 5 times 2. 5 times 2 is 10 times 11 is 110. So the result has to be 2 times the square root of 110. And in this case, the units are going to be square centimeters. Done. This is the exact value of the area of this triangle we have here. And before you leave, I'm going to ask you to solve this homework exercise. The sides of the triangle are 16 meters, 10 meters, and 10 meters. Please do it using Heron's formula. And when you have the answer, put it down here in the comments. I'm going to give a nice big heart to everyone who gets it right. And well, that's all for today. I hope the video was helpful, but most of all, that you enjoyed it. If you liked it, please subscribe to this channel. I upload videos every day. See you next time. Take care and behave well. Bye.